Deliver the second lecture of chapter number 1. The chapter number 1, the name of chapter is electrostatics. This is topic name is electric field and its intensity. It is given on page number 7 in the book class second year. This lecture is aimed for explaining the electric field intensity. As already discussed in Coulomb law, that static charges possess electric field around them. So today we are going to explain what is electric field and what is the electric field intensity, and finally we will be deriving an equation for electric field intensity for a single static charge. We are going to explain what is electric field. According to definition, electric field is the space of region around a static charge which has some electric effects when a test charge is brought near to the charge. For example, we say that this is a charge positive which is having electric field around itself, that is shown by the red lines around the charge like this. This is, we can say, this is the space of region where the electric effect of this charge is felt whenever a test charge is brought near to it, like this. This is a test positive charge. Test charge is that charge which is used basically to test another fields, another charges, and the charge which we are going to explain is called the source charge. So every charge is having its own electric field around itself. Electric field is basically a vector field. Vector field is that field which is having a specific direction. So for positive charge, the direction of the electric field is radially outward, and for negative charge, the direction of electric field is radially inward, depending upon the nature of the test charge. Okay, so this is electric field. Next, we are going to explain electric field intensity, EFI, electric field intensity. Electric field is having its own intensity. It is having its own energy depending upon the magnitude of the source charge. So, to explain electric field intensity, let us we have a source charge positive and we bring a test charge positive close to it, where R is the distance between both the charges. So the intensity of this charge, source charge, in order to calculate the intensity of the source charge, this one positive charge, that is, we can say that electric field intensity is force per unit test charge. The force experienced by the test charge coming from the source charge defines the electric field intensity of the source charge. Then this is the equation, this is the definition, this is the formula for electric field intensity. So the unit of electric field intensity is, looking at the equation, we can have that Newton per Coulomb is the unit of electric field intensity. That as electric field intensity is a vector quantity, so it must be having a magnitude and a direction. So the magnitude of electric field intensity is shown by the equation above. E is equal to F divided by Q naught. So, and the direction of electric field intensity is along the direction of the force, along the direction of the force F. So this is electric field intensity. Now we are going to derive an equation for electric field intensity for a single static point charge. Derivation. For deriving the equation for electric field intensity, let us we have a source charge S that is taken as positive charge, for example, and we bring a test charge close to it. So according to Coulomb law, the force exerted by the source charge upon the test charge is shown by the equation F is equal to K Q1 Q2 divided by R square. This is equation number 1, and where Q1 is taken as test charge, so we can write it as Q0, and Q2 is the source charge, we can take it as small q. So this is the force acting upon test charge Q0 coming from the source charge Q. So putting the values, we can have F is equal to K Q0 Q divided by R square. This is equation number 2, which we have taken from equation number 1. So putting in the definition of electric field intensity, that is E is equal to F divided by Q0. Putting the value of F in this equation, we can have K Q0 Q divided by Q0 R square. Cancelling Q0 from numerator and denominator, finally we can have electric field intensity equation as K Q divided by R square. This is our desired equation for electric field intensity for a single point charge, and that's all. Thank you.